All right. So last time I floundered around quite a bit around all this mixin, monad, extension stuff. Um, so what I'm gonna do today is try to create some mock up some concrete examples. That way I can really demonstrate what's going on, what we're trying to accomplish here. Um, and so I'm gonna do that in this extensions class. I'm gonna try and keep the non-mock-up stuff where it's supposed to be. So let's play with some examples. So let's consider some concrete context. So something like a calendar events context. It knows what it's talking to, it knows how it's supposed to work, and it knows what capabilities are available to it. So let's say public seal class uh, knows how to wear. Uh, so this is going to be an iQuery context. Um, okay, what should our response and our value be? So what I'm going to do, mock response, mock value, and so now we're going to use mock response, mock value, and to error. Sure. All right. And again, the idea is that this one knows how to wear. So it will have still a mock response, mock value, and mock error, and it will be a knows how to wear. Whoops, knows how to wear context. So we'll also implement that. Um, and I don't think we actually need to um, do implementations for these yet. So what we're trying to do in addition to this, um, sorry, the ground. Oh, I should probably move this outside of the extensions would be helpful. Okay. So here, uh, let's say that we have knows how to wear context, and it says we evaluate that, or rather, we great. So all my examples here are going to use concat as well. So I'm gonna build a concat. You know what? I'm actually just gonna copy it. All right. And this says it returns a T query context, but it's really not. Alternatively, maybe we should restrict it to only concatenating with other C query contexts. Um, okay. Regardless, we also want an I-concat query context mix in mock response, mock value, mock error, um, and knows how to aware context. You know what? Actually, the whole thing about this second, the T query context, I am going to do this to T. Whoops. Okay. And now let's implement this. And so now let's say, uh, got another one of these. And so now we can concat them. Great. Um, Bummer. Yeah, it really only makes sense. I'm gonna take this back again. Hmm. And as a result, this doesn't need a T query context. Okay. Okay. So now we have this and this. Okay. So now concated dot where, we can't call where. Yeah, sorry, that's the point. So what we can do with this, um, what we are able to do is knows how to dot where some predicate dot concat uh, with the second one with that same predicate. So we're able to do this. Um, However, we are not able to do this. Um, there's nowhere on concated if you do it with the concat first. Now, we can kind of know, right, if you concat something um, and then you wear it, it's the same as wearing as wearing the first, wearing the second, and then concatenating the results of those two wears. And so that's something that maybe we want to light up, or we want to introduce a helpful extension. Um, Helpful where concat extension, for example. And so this is going to be T response, T value, T error, and it's going to implement I query context, T response, T value, T error, and it will, um, if you concat, yeah, so it'll implement concat. And it will take in another query context. Let me look at my monad for the moment, which we know the type of. So we are going to need the type of this. So the query context, the query we won't do that yet. Um, but this will take in a query context source. And so now, if you concat, what that means, if you evaluate, we're just going to do whatever you want it to do. Just source evaluate. Uh, where T query context and I query context, T response, T value, T error. Okay. Um, and in fact, in our case, so if you then concat, we're going to have a where query context that we return. Uh, so this is going to take in pquery context, source, and iQuery context second. Okay, so now if you evaluate, we've not actually done anything special. We have nothing to add to the let's return new concated t t concated source second. So if you just evaluate after that, so if you have this and you wrap it in this and then you call concat and then you evaluate. We've got nothing to add. We aren't doing anything. Only if you subsequently where do we do something. So in this situation, the evaluate here is return this dot source dot concat. Oh yeah, okay. So for this whole thing to work, T query context needs to be concatable. So we gotta put that generic type constraint as well. Great. So now dot concat this dot second dot evaluate. Two things are mad at this. That's not cool. Okay, wonderful. Okay, so if the caller calls concat, we're just going to actually pass that through to sources concat. But if they call where next, um, so second also needed to be wearable. Um, so we knew first had to be wearable. All right, so we'll see how many times I go back and forth on this. I do want a T query context. Um, where T query context, query context, T prompt, T value, T error, T query context. We don't have that for query context. And then we use T query context here. Okay, so now this is going to be a node of where context. And in concat, we're going to need to replace it with that. This we should return this. Oh, that's a real bummer. Okay. This does need to return T query context. I'm starting to get the impression that I can't do what I think I want, what I want to do. Um, yeah, because we have to return a T query context here, but we really should be returning the extensions. This is it's not good. Yeah, because yeah, it has to return. If I get really bad here, this is definitely wrong. But let's see what now happens. Let's just try this. See if we can forward for a minute. That didn't fix it. All right. All right. Uh, all right. And now here, yeah, we'll keep that the same, but this should return query context. Okay, it's better. And so here, this should now be the T query context. Query context. Okay, now we're getting somewhere. So now if they call where, this returns concated. Yes, good. Okay. So now if they call where, what we actually want to do, we're going to need another type. This is, we have nothing to add in this situation. So I query context, T response, T value, T error. Um, and so where is going to get these fun things, and it's also going to get the predicate. All right, so now to evaluate what we're going to do, because normally what would happen is you do a concat and then you do a where on both. We don't have a where available. This makes the where available. Um, so we're going to return source.where this.predicate dot concat this second dot where this dot predicate uh, dot evaluate. Okay, so now concatted dot, it's still nowhere, right? Um, but what we can do is say uh, our helpful extensions, helpfully extended, new helpful where concat extension of knows how to where context, mock response, mock value, mock error, and we take in the knows how to where context. Fascinating. No implicit conversion to the concat mixin. Um, okay, let's look again. Knows how to where context. I use say for query context. There's no implicit conversion from knows how to where context to I concat query context, mock response, mock value, mock error, knows how to where context. Oh my jeepers. Okay. All right. Now it's good. All right. Now we can helpfully extended dot cat with knows how to where context. And now we can dot well, we're supposed to be able to, and that didn't work. So let's see concatted dot where. This concat still returns the iQuery context. Yeah, this is all going very poorly. Okay. So what's my use case? Yeah, I think that's where I'm messing up. So I had this whole thing in a different repo with enumerables, and I was using monads and mixins, and it was quite powerful. And so the idea was, um, when you evaluate the calendar events context, we get the instance events and we get the series events. And getting the series events is this interesting um, interesting thing that happens where we have to get these series masters, and then we use those to get the instances in those series. Um, so the the issue very early on when I was doing all this before I really fleshed any of this out was that um, it would uh, once we return to all of the calendar events, then over here in the to-do list service, the next thing we're going to do, calendar events context, we're going to say, okay, and now filter some more. And so what would happen is when we do that filtering, that subsequent filtering, um, we would have gotten all the series masters, and so getting the series master and the first event in the series, and etc. All of this was Paul's uh, part. Yeah. All of this is going to be network calls, and so but the issue is, in addition, later, like here, we filter by the subject, and we can't actually filter by the subject on the server. Um, However, no, let me back up. With these two, right, is not canceled, for example. Um, yeah, sorry. Once we've evaluated and given back an IEnumerable, we already have all of the things that are canceled or not canceled or whatever. And so what would end up happening is on the series event master, we already could see if it was canceled. Um, but we weren't able to actually leverage that to know to filter it out here in this step before we ever bother to try and get the first instance in the series. So we wouldn't have this part. We're now able to do that because this implements the where mixin, so it records um, the case where it's canceled, and if it is canceled, then or all the cases where it is canceled isn't null. We actually now know to look for that. So we get those wheres and we actually record them and make use of them so that we don't make those unnecessary network calls to get the first instance when we don't actually need it. Um, what still happens here is, and at the time I was using only enumerables when I was discovering all of that, and so I was able to do these interesting things with monads and mixins on enumerables. Um, but the reason that was so powerful in enumerables is because we always had a default implementation for the extension. So all this stuff that I'm running into over here, like um, I need to say that the T query context is concat and where, and I need to do that only because the concat here needs to be able to take in something that's also wearable down here, so we can know that we can do this second where and stuff. Um, and all that's entirely avoidable with enumerables because um, if second doesn't have it is not a where mixin, we have a default implementation for where. So we can still know that there's going to be benefit if the source is wearable, because we know that if you where first where the source and then concat it with a where'd second. Like worst case scenario is we do the better improve we do the you do the optimized thing that source knows how to do for where, and then on second we're going to just do the default implementation. But that's at least better than concating them and having to do the default implementation for the full concated list. Um, so in enumerables, the fact that it's a monad already is really beneficial. But in this case, the query context itself is not this kernel thing that we can do. Like not every query context is going to be able to where and concat and stuff. And so I'm running into all these things where I need to have all these type restrictions. And in fact, I was letting that influence temporarily. I was going to clean it up, but influence the method signature of the concat mix and things like that. But I think what's actually happened is that's no longer relevant because as I mentioned before, I don't actually leverage the monad stuff in query context in the calendar context right now. So over here, when I do these two wheres, there's nothing bad that happens here. Um, in that the calendar events context already is accommodating these things. They're not like happening in memory or being delegated to a default implementation. They're actually being uh, leveraged before we even go on the wire. So that's all great. Another thing that is happening though here, and I want to think about if we need the monads to solve this, the monad mix and stuff to solve this. Because another thing that's happening here is that the calendar, we're also subsequently, once we've called evaluate, we have the calendar events. Now we want to filter by two more things. And this is where it gets bad, because once we've evaluated, these are in memory. But um, we do know that the to-do list is or the subject. We know that from the event series event master, and so here this filter, the hope is that this can be looked at and applied uh, on the series event master up here before we ever actually have to try to get the first instance. And so that's what I'm looking to get at. This one, this start here, um, that actually must happen and that must not happen in memory. That can also be applied, but at the first instance in series part. So instead of having to do it in memory, we could actually only get the first instance in the series if we could let the server do the work for us. So these two things that are currently happening in memory um, are we want to be able to push back to the calendar events context, push it back in the processing pipeline. So, um, oh, and what I've noted here actually, we will need to do this part in memory anyway, because of this bug here that I've noted. So this part will definitely happen later on. Original last report timestamp. So yeah, so we're already leveraging this part, the second where on the in memory portion. So we need to push this part up into the calendar events context. So what's going to be annoying to me about that is it means that sometimes, no, 100% of the time in the calendar event context, we're actually going to be applying this in memory. It's just that if we can apply it to the series event masters, we're able to avoid network calls of subsequent first instances in the series. Um, and regardless, we do still need to filter everything out by in memory. So for the instance events, for example, that's going to still be 100% in memory filtering. So we don't actually, we're only sort of benefiting by pushing this higher up. Um, and we're benefiting greatly, but it's a bit obfuscated, I would say, because um, yeah, it's only It's only that one specific case that we're benefiting from. So, for example, if you only had series instance events, this happening in the calendar events context doesn't actually do anything. It's like yeah, it's no different than just doing it in memory. Fascinating. But we can just push that into the calendar events context. So all this monad stuff that I'm interested in, um, yes, let's go back here and see. Uh, because I think my conclusion is starting to become that the if you have a monad, no, because it's still not necessarily a kernel. If you have a monad that implements everything, then maybe you can do something. Um, I'm also actually not clear if that concat uh, does much of anything. The concat mixin, because this is a query result that I'm doing concat on. Yeah, because for query contexts, what does it mean to concat two things? It doesn't mean anything really. Um, maybe it does. Maybe it does. But like that concat, maybe it's doing something in memory. I'm not really clear. It's not strong type. That's what I want to say. It's not strong type. Kind of no matter what you do here. Like if we're linked to SQL, for example, and someone calls concat on us, like yeah, if we know both queryable and we know that they're both in our database and those things, like we could do something where we throw the two responses together into a single response, and that's probably more optimal in SQL in some way or something like that. But like 99% of all queryable will not be a valid queryable to concat with. Um, and so I'm very inclined to not allow those cases. Like I don't want to let the API give a facade that it does do certain things that they're actually not supported or just not even possible. I call that overexpressive and overexpressive API. So I think where I'm landing here is that I don't need the monads. I need the mixins, but I don't need the monads for query contexts, which is kind of a shame because I was doing some interesting things um, with that in other places. Yeah. Okay. No, that's fine though. We don't need to do stuff that we don't need to do. Um, yeah, so we don't need any of this. Wow. So where query context mix in though, it does need, and that's just the query context needs that. Okay. All right. All right. I can accept defeat here. I need to find somewhere to put some of this old code that like this stuff is there's something here. This is good stuff. Um, I gotta find a place to put this. Oh, I already have a. Okay. All right. And now let's do this. Uh, cat. And now, yeah, this is doesn't really need to implement query context. You can't return. No, but what the? Yeah. No, it does need to just like conceptually. Okay. Yeah, we're gonna remove this for now, and we'll add it back if we do want that convenience overload. Um, so here, I've already made a note elsewhere to do this. Okay. Uh, yep. On this, I think argument null exception makes sense. And then what else can happen? So I don't remember if I did anything smart over here documentation wise. Um, what did I do in my where method here? So yeah, we need some way to say that it's not supported, that the predicate provided isn't supported. Is that just a not supported exception? Predicate represents a filtering that is not supported by the backing data source. I think that's sufficient, probably. What are other cases where this can go wrong? I mean, it can't really go wrong, right? We like if we got a predicate, we got a predicate. It's an expression. Expressions aren't going to be constructed in malformed ways. They're just going to be constructed in ways that we don't understand, which is just not supported. So I think we're good. Okay. Um, yeah. So I'm gonna make a note, another note to add more query context, mixins. I do wonder if there's something with monads that would make sense to do. Um, let's take a moment to just look at some like queries, like what's available. Uh, what's that? This one. So yeah, what might distinct? What's distinct do? Or is that maybe a case? So distinct is really aware. In memory, it's really aware though. That's not really. Okay, so yeah. Okay, maybe distinct is our use case. So if we distinct, it's concat plus distinct. How about order by? What's order? So if you order have two that are ordered by, and then you concat. If you have two that you concat and then you order by, concat doesn't make sense. So we're not gonna do that. So okay. Um, except intersect. Yeah, anything that involves a second queryable is not really gonna help us. Order by distinct. Oh, order by where? Yeah, any order by where is might make sense. So maybe we try that. The idea here is that if you call order by and then you call where, we should actually where first because order by is going to be um, well, that's really only true in memory. Yeah, if you order by and then where, and query context is able to support both, it really should be the one who does that, who makes that decision. I guess maybe that's the point though. That if you know if it doesn't do that and you can write some extensions because you know better. Yeah, that is the point. Okay, so order by plus where is what we're going to try to do. Um, I'm gonna go ahead and code review this one new thing that we've now added that just this makes in, and then we can jump into that. And I might actually be done after we code review this, but then we'll do that next time, I think. So, all right, we need our okay and I query context. Yeah. All right. Okay, we got our comment line, namespace. So right namespace using statements. We don't have anything. We don't have a class here. No precondition checks. Um, evaluate exception documentation. Evaluate. I do kind of wonder if this should throw something if the very first request does produce an error, or if it should. I'll talk to somebody about that. In the meantime, I'm going to say no because we have T error to actually accommodate those situations. I didn't mean to close that. Yeah. Um, exception explanations, do's, no. All exceptions, we haven't written anything in here. Pragmas, limos, we don't need any unit tests. All right, things are looking good there. Here, all the same stuff. Placeholder, do, pragma. All right, cool. So then let's actually implement that. Not there. Let's playground. All right. Our situation was one where you can wear and where you can order by. Wearable and order buyable. Query context. No, let's chat. Delete all that stuff. Lock response. Lock error. Lock value. Okay. Response, lock value, lock error. It's also a where mix in mock response, mock value, mock error, where order wearable. There we go. And it's also an I order viable, which I haven't written yet. So let's add that interface here just to have it available. Demonstrate. I ordered by, let's actually um, write this out. So it's not going to be a predicate. It's going to be uh, what is it? T source, it's T response, and we got T key here. And this is not a T query context. So, oh, neat. We're going to return a different thing. Okay. So here we got mock response, mock value, mock error, and we need another thing. Code field class ordered results context. Uh, implements this. So implements I query context, mock response, mock value, mock error. And so this is going to be an ordered result context. Okay. Well, it's ask Visual Studio to stub those out for us. Nice. Okay. So now I managed to still call this where order by. uh, Full excited review. Okay, so we can say context order by um, self, I guess, for now. But we can't call where after that. And we can say context dot where dot order by, and that's all fine. But yeah, if we wanted to order by and then do a where, um, what would we need to do for that? Um, yeah, and to be clear about this, this is a terrible uh, actually if this T theory context needs to be something that in the framework indicates that it is ordered so that then by can be called on it. So this could, right, return itself. In which case, though, if you then subsequently call order by, you'd lose. the first order, or it would be ambiguous what that means. Are we doing a then by, or are we doing a full new order by? It really should be a full new order by because there's nothing that guarantees that like the result of this doesn't get passed to some other method that has no idea that you've already called ordered by. Like that's why we need a new type for it. But that's not really relevant to us here, so I'm just gonna not put it in yet. Um, okay, so from here, we should have the extensions. So I'm gonna write that. Now write a helpful extension that allows a where after the order by. It's called. Um, yes, okay. I think this does actually demonstrate is able to demonstrate it. We'll see next time. I might bang my head against the wall again. But if not, we'll get to probably work on some interesting stuff. That's all I got for now.